Of a combining of skills where you look at the question, it's not that wordy, but it is a sentence, and so we want to look for what is the question asking us to do, and it comes right out and says it pretty clearly at the start. I mean, the key word to me is find, and it says find the equation of the tangent line. So in the end, I need to have like some kind of a y equals mx plus b or some version of that. Once I have that, I know that I've at least reached the conclusion that they asked me to reach. So let's practice this, okay? This is a good chance that I think this is like the 4th or 5th time we've done like the equation of the tangent line. I hope you're starting to get the idea that this is a common question. It will be asked quite a bit, right? So what are the two things you got to have to find the equation of a tangent line? Point of tangency and the slope of the tangent line. Of those two things, which one was just given to me in this case? The point of tangency is right there. It's 1, 4. So the main thing is going to be finding the slope of the tangent line. What is the slope of the tangent line describing? The derivative, yeah, dy dx, or in this case we could write it as f prime. So why would this question be in the chain rule section of the book? Because you got to use the chain rule to find f prime, right? How do you know, like why would you select the chain rule as the proper procedure here? Like what tells you that you've got to use it? Yeah, you see the boxes, the parentheses, it's composite. Composite is right. So f prime equals, let's practice this. Any volunteers? F prime? Go ahead, Catherine.
F prime x is 2/3 times 9 minus x squared to the negative 1/3 times a negative 2x.
She's definitely executed the product or the chain rule correctly. She got the derivative of the outside. She multiplied by the derivative of the inside. She's done a great job. Do you have any questions about that, what she did? Any of the details in there? Hope that you've been practicing your WebAssign. I have not recorded those grades yet. I'll do that sometime today. With 2.4b, I guess, was due last night. So if you're doing great with that, then I hope this made sense to you. At this point, we got to realize what we've got. Remember, the goal here is to find the equation of the tangent line. We're trying to find the slope of the tangent line to help us here. What is that thing right there? She found it for us, but what does it mean? What is it? It's the slope anywhere on this curve, right? We don't care necessarily about the slope anywhere. We want to know the slope where? At 1, 4, at the point of tangency. So how do I do that? Like, how do I turn this into the slope at my point of tangency? It's a plug-in, right? Yep. So I'm going to plug in. The only appropriate plug-in here is the x value of 1. So I'm going to write f prime of 1 equals 2/3, and it's going to be 9 minus 1, which is 8, to the negative 1/3 times negative 2 times 1 is just negative 2. Anybody know 8 to the negative 1/3 off the top of your head?
Negative 2.
No? 1/2. It's 1/2, right? Doesn't the negative 1/3 mean flip it down? So it's really this. I'll go through the steps for you. F prime of 1 equals 2/3. It's really 1 over the cubed root of 8 times negative 2. So the cubed root of 8 is 2, and 1, so it's 1/2. So what do we get? Negative 2/3. So at this point, I've got my slope of the tangent line. I've got my point of tangency. Let's try to put it all together with maybe point slope form. As you guys know, I like that. So it'd be y minus 4 equals negative 2/3 times x minus 1. Feel free to convert that over to slope intercept or some other form. I don't really care. I kind of would like it if you left it there, but whatever. Do you have any questions? Good? Feel free. Come on, say something. Yeah, Matt, go ahead.
Yes, so
Listen up, please. This could be your question, too.
I'm just a little confused how you got to the 2/3 because, like what is, you multiplied 2/3 times 1 over cube root of 8?
Well, the cube root of 8 is 1/2. Because 1 over the cube root of 8 is 1/2 because cube root of 8 is 2. So that's a 1/2. So half of 2/3 is 1/3. And then multiply by negative 2, you get negative 2/3. Good question. Details even, or little tiny details like that. Definitely important questions to ask. Anyone else? All right. So this has been day 3 of the chain rule. And that in addition to the couple of days, hopefully at least that you spent on the WebAssign, I hope this has been a good attempt at you guys getting good at the chain rule. We'll keep using it here today, but these are all kind of like your basic chain rule skills we want to be really good at. We'll keep practicing. We'll do the chain rule for the rest of the year, but at this point, before we close it up, I want to make sure you're okay. Is that true? All right, fair enough. Let's move on then. We're going to take a look here at 2.5. Obviously, there's a video here based on implicit differentiation is the idea. I hope that you watched this. I'm trying to remember, did I talk about trees or smiley faces in the video at all? Okay, good. I just can remember if I'd done that. That's still in my toolbox to use if I need to help you with how to do these. Okay, guys, we're going to skip around a little bit. Let's leave number 2 for later. Let's leave... Let's leave number 3 for later. Let's do number 4. We'll skip around a little bit here. I apologize for that. It's going to kind of scaffold this a little bit for you. So let's do number 4. Number 4 says, find the equation of the normal line. I underlined that right because it's different than tangent line. And so let's take a minute and talk about what that means. If you've had physics, this means the same thing it does in physics. What does normal mean in physics? Perpendicular. Yep. It means the same thing here. So find the equation of the perpendicular line. And I want to explain what this would look like on a graph too. So perpendicular is what normal means. So let's take a look. You've got x squared plus y squared equals 25. What is that graph, by the way? Circle centered where? Radius 5. Okay, so I'm going to just sketch that out. It's going to be a very basic sketch. Whoops. Y-axis, x-axis, circle. Okay, so the point 4, -3 is right there. Something like that. So I'm going to sketch something in. You please tell me what this is if you know. It's intended to be a tangent line, right? Does that make sense? So the normal line would look like this. It would be perpendicular to the tangent line at that point of tangency. Okay, so let's keep that in mind as we go here. There are a number of ways to execute this. I'm going to choose to do this to kind of show you the process, and we could talk about maybe an alternative way to think about this if you want. So here's what I'm going to do. We're going to use implicit differentiation for this, and hopefully we'll see how much you picked up from the video here in a second. My goal is going to be to find dy dx, because I know that dy dx is the what? Slope of the tangent line. So I'm thinking if I could find the slope of the tangent line, couldn't I just do some little algebraic manipulation with it to get to the slope of the normal line? So does that seem like a good strategy? There's other strategies, but at least that seems logical, I hope. Okay. So here's where we get to test out to see how much you know from the video. I've got x squared plus y squared is equal to 25. If my goal is to find dy dx, what should I do? What do I need to do to that? Say again? Yes? So it's not really a multiplication, right? I would say we want to do ddx, and so Hannah said it too. She says we need to do ddx. So I want to at this point make a point of emphasis that, can you see that? It did show up. Okay, good. Okay, so I want to make a point of emphasis that ddx is like a verb, like it's an action. ddx is saying, do the derivative with respect to x of the thing that comes next, right? It's an action. And so in the end, don't write this down. In the end, we're going to get like a dy dx in there somewhere. dy dx is not an action. It's a noun. It's a thing. It's the slope of the tangent line. d dx is the process of doing the derivative or finding the derivative with respect to x. So let's see how you do with this. I'll take volunteers. I'm going to do d dx of the first term. What's d dx of x squared? Zach?
2x.
It is 2x. You are 100% correct. Take volunteers for the next one. What is d dx of y squared? Lainey?
2y times dy over dx.
You got it. 2y times dy dx. If you watch the video, the hope is that you understand why that showed up there and not on the other one. And then finally, take volunteers for the last one, d dx of 25. What is it, Caitlin?
0.
0. Yay, we like that one. Okay. I'll stop right there. Does anybody have any questions? Why is it that way? Why isn't it this way? Where did that thing come from? Anything like that. What if we did this? We're all good?
It's the big deal if one like a test would write 2x times dx over dx.
I got no problem with that. I mean, I hope the very next step you'd be like, oh, that's really just a factor of 1, so I'll just, cancel those out. I guess I would hope that eventually you wouldn't do that, but if you did that kind of at the start to kind of help you understand the consistency of it all, I got no problem with that. I think that could be a valuable tool for you. Fantastic. Okay, so now we're going to solve for dy dx. So this is just a little bit of algebra. So dy dx is equal to negative 2x over 2y. So dy dx would equal negative x over y. Still making sense? Okay, so let's describe that. Like, what is that? Really important that we always understand. Like, we completed something. What is it? Slope of the tangent line. Agreed. Where? Anywhere, right? At any x, y on the circle, that's the slope of the tangent line. We want to know the slope of the normal line. Let's go ahead and find the slope of the tangent line at our point of tangency. So I'm going to write this. I'm going to say dy dx at the point 4, negative 3. dy dx at 4, negative 3. This is just a plug situation, so I got 4/3. So again, it's really important that we understand that that is the slope of the tangent line at the point of tangency. We are going to try to do the normal line, though. So I'm going to put over here, normal line. And we know from before, like you all said, at least those of you that are in physics have done this a lot, right? Normal force. We want actually to know the slope of the normal line. So I'm going to put maybe this. This is one way of noting this, perpendicular slope. This is supposed to just be like that. So what do I need to do to 4/3 to get it to be a perpendicular slope? Negative reciprocal, opposite reciprocal. So in this case, we flip the 4/3 to get 3/4, change the sign. It's negative 3/4. So once I've got that, I've got my point of tangency. That's still going to be the point that the normal line goes through. I've got the slope of the normal line. Just like our warm-up earlier, we just got to put this together. So we'd write y minus negative 3 equals negative 3/4, parentheses, x minus 4. That would be the equation of the normal line. Question, Matt?
Can you just write that as y plus 3?
Absolutely. Yep. Jake, go ahead.
If that was on a quiz, how would that be graded?
Like, how would the points work out?
Yeah.
Good question. Let me think about that. I would... If this question were the whole complete question were on a quiz, I would definitely place a premium on kind of like seeing that you can do this process, like do ddx correctly with implicit differentiation. So I think I'd say something like first point would be, does ddx correctly? Like the student did ddx correctly. That would definitely be the first point. I probably would give you a total, wow, yeah, that's a great question. It'd probably be, since this is a normal line, it would probably end up being a 4-point question. I'd say something like, gets to, like, there's an alternative method to this, and so I would say, like the second point would be something along the lines of, shows that they understand that the normal line is just the opposite reciprocal slope of the tangent line. There'd be like a number of ways to get there. And then I would say, correct answer with the tangent line equation. Maybe a 3 or 4 point question, but I would definitely place the emphasis on the calculus. I don't know that, so to me, like going from here to here is all about algebra. I don't know that that's worth like a whole separate point, but understanding the difference between a normal line and a perpendicular line, or a normal line and a tangent line, to me, that gets at a concept that's tied to calculus. So, yeah, good question. I guess I don't totally know exactly what I would do with that. Catherine.
If you give us the point of tangency for problems like this, will you always give us the x and y?
Not always. Might just give you the x.
How can you calculate 3?
You'll see in a little bit. I'd have to give you a little more information,
Okay.
right? Because you should get 2 of them,
Right.
right? So I'd have to give you a little more information. If I gave you just an x, I think you'll see one here in a second.
Okay, perfect.
Okay, any questions? Okay, so I think this next one is sort of like that one. Some similar skills, so I think we'll build off that. Yes. So Catherine, maybe this will kind of answer your question. So number 3 says, find the equation of the tangent line in the first quadrant for the ellipse x squared over 2 plus y squared over 8 equals 1, when x equals 1. Let's just stop right there. Then we can do the whole estimation thing that it goes on to ask us to do. We'll do that later. For now, let's do what it asks us to do. Let's find the equation of the tangent line in the first quadrant for that ellipse. So let's just start right there. So we basically just did this. We found a normal line, but that's actually a little bit easier than finding a tangent line. See what you can do with this one. Maybe before we totally get rolling with this, does anybody see maybe like something that would make this look easier, like a little algebra step we could do? Multiply everything by 8. Strongly suggested. That gets rid of all the fractions. Hopefully eliminates your possible falling into the quotient rule trap. So I would do that. So if you multiply everything through by 8, you get 4x squared plus y squared equals 8. So use that. Find the equation of the tangent line in the first quadrant when x equals 1. Check to make sure we're all on the same page. I've been watching you all working here. Bianca, would you mind sharing with us what you did first? So again, just make sure we're all on the same page.
I did the ddx of 4 plus y squared.
You guys agree with that? Did you do the same thing as Bianca? DDX of everything? Okay, that's right. Keep going. What'd you get when you did that?
I got 8x plus 2y times dy over x equals 0.
Also correct. Okay, great job. So I hope you got off to the same start as Bianca. If you did, you're in pretty good shape. I'll let you keep going, working on the equation of the tangent line. So doing a little arithmetic, or I guess algebra, we should end up with dy dx equals negative 4x over y when you reduce. Make sense? Okay, Eliza, what would I do with that to progress? Yep. And we only have the x value, right? So what did you do to find the y value? Yeah, so you plugged the 1 in there for x or y? Okay, so 4 times 1 squared plus y squared is equal to 8. Subtract the 4, square root, what'd you get? And we would use the 2. Why would we pick the 2? Because what? First quadrant, yeah. There really could be plus or minus 2. You'd have to consider both, perhaps. But it does say first quadrant, so we're just going to go with 2. So, Eliza, let's finish this part off at least. Dy dx at our point of tangency, which is 1, 2, would be what? Negative 2. Okay, so that's the slope of the tangent line. And in the process of finding it, you found the point of tangency also, right? So, Lainey, what would your equation of the tangent line be?
1 minus 2 equals negative 2 times x minus 1.
looks great. Nice job. You guys have any questions so far? Yes, ma'am.
Did it say the first quadrant? Would you have to do both?
I guess you'd have to do both, right? Because x equals 1, there's 2 different points there. So, one time your slope would be -2, the other time would probably be +2. So, yeah, but I'll probably try to kind of paint you into a corner with that. I don't want to leave that open to interpretation too much. Yeah. You guys have any questions? Follow up on what we've been led to here? So we completed the first part. It says then, little transitional word here, then use what you just found to estimate y of 1.1. So let's go ahead and do that. So here's how we would do that. I would write y minus 2 equals -2 times 1.1 minus 1. I'm just taking 1.1 and I'm plugging it in for the input of the line because I'm going to use the line to estimate the curve. Of course, 1.1 minus 1 is 0.1 times -2 is -0.2. So y minus 2 equals -0.2. I would add 2 to both sides and I would get positive 1.8. That would approximately equal the y of 1.1 that we see on the ellipse, 1.8. So pretty common ask, as far as saying, hey, let's take your line and use it to estimate the curve. The bottom line is it's easier to use a linear thing than a curvy thing, right? It's always easier. You guys have been good at lines for a really long time, so it's easier to use that. So that's one of the reasons we would estimate with a line. Final question. I don't know how you're going to answer this, but that estimate of 1.8 using the line, it's not perfect, right? It's not exactly the same as the value of the curve, but do you think it is higher than the curve or lower than the curve, and why? What do you think, Johnny?
I think it's higher because I think due to the severity of the negative slope.
The severity of the negative slope does what?
It increases. Like the slope will increase, but decrease, I guess, because it's negative.
Get more negative?
That's what I meant.
Fair enough. So you're referring to a graph, kind of?
Yeah.
So let's look at a graph. This ellipse, would you guys say that this ellipse is one of those tall, skinny ellipses, or kind of one of the short, fat ones? It's tall and skinny, right? Because the number under the y is bigger than the number under the x. So I don't know if it's all that tall and skinny, but something like this.
Sure.
So the point 2 or 1, 2 is right about there, roughly, right? The tangent line is then going to be something like that. So can you see how up there in that first quadrant, isn't the tangent line always going to be higher than the curve? And the way you're saying it, like the negative slope will get more negative as you go to the right. To the left, actually, it gets less negative, doesn't it? It gets closer to 0. I would look at this and I would say this is more a function of concavity. We haven't really talked about that word yet. Do you see how you could describe the first quadrant as being concave down? That's what's really causing the line to be higher than the curve. Or I'm getting a little bit ahead of myself at this point, but I just want to kind of plant some seeds that we'll try to work with a little bit later on. But I would agree with you, Johnny, that the estimate is too high. And the reason is kind of the nature of the curve, right? Like what the curve actually looks like. We'll get into the more technical aspects of that later on. Okay. You guys all still doing okay? All right. So I think we got 2 other examples to work. So let's do those. We did that one. We did that one. Do I want to do 2 or 5? I want to do 2. You guys are quiet. Does this one look scary? Kinda. Okay, so let's do this. The instructions, by the way, sorry, the instructions are kind of cut off. The instructions say use implicit differentiation to find dy dx. So numbers 1 and 2 use implicit differentiation to find dy dx. Okay, you kind of have to. You don't really have a choice on method. Before you just like run off and do this, I want to point a couple things out, and then I'll let you run off and try this. This will be a challenging question to get all the details in the right spots and all those things. So I want you to do your best, but let's point this out first. What do you see there? A product rule, right? It's x squared times y, so you got to use a product rule. What do you see there? Another product rule. So there, as you do your DDXing of stuff in there, you should come across two distinctly separate product rules. That'll provide a good challenge for you. I'll give you, I don't know, give you 5 minutes, couple minutes here to try to work this through. If you get stuck, that's fine. I'm coming around to answer questions for you, but I think you get the basic process. Let's try to apply it to this. All right. So guys, remember the goal is to find dy dx. So since the goal is to find dy dx, we're supposed to do ddx of everything, right? So that's what I'm going to put here in parentheses. I'm just going to say, I'm going to do ddx of everything in the parentheses. Nick, would you mind helping us out a little bit with that? Sorry, that first one there, I need to unfreeze it. So what do you think, ddx, how would we start off with ddx of x squared y?
All right.
Yep.
X squared, and then derivative of y, which would be y dx.
So that's basically 1d2, right?
And then plus y times 2x.
Okay, so basically what he's done, and he's done a nice job of it, he has done the derivative of that first term, right? Can I ask you kind of a devil's advocate sort of a question, see if you know the answer to it? Why is there a dy dx with the first term, but not a dy dx with the second term? Dx over dx cancels. Yeah, technically he's right that there would be a dx over dx. I'm not going to write it because it is just one. What did we do to the first term? What was going on with the first term that's not going on with the second term that causes that dy dx to show up in the first term but not the second? You're doing a ddx of y, right? Did we do a ddx of y in the second term? Nope. In the first term we did. That's why it's there with the first term but not the second term. All right. Cole, would you help us with the second term? So this one right there?
Y squared plus 2y back times dy dx.
Can I squeeze that in right there? Make sense? What you said is definitely correct. Okay, so Cole has done 1d2 plus 2d1. What do you guys think? He did it right. Well done. Okay, I'm encouraged. Do you have any questions so far? Okay, equals what? 0. Yep, that's kind of nice. All right, so the goal is to get dy dx by itself. So what follows? Basically, at this point, I got to be honest with you, you have done all the calculus that you need to do. Is this a little too crowded right here? Let me fix that for you. Is that better? I kind of crowded it in there. I shouldn't have done that. We've done all the calculus we're going to do on this question. What remains is algebra. I didn't say it was easy. I just said what remains is algebra, right? Okay, so Jake, what would you do first in our efforts to get the dy dx by itself?
I would subtract by y times 2x on each side.
Okay, so I'll just put equals negative 2xy. Just do a little reordering there, but
Yeah.
okay, I like that. What else?
Could subtract the y squared.
Agreed, so I'll subtract that over. Are we going to subtract anything else over at this point?
No.
Okay, so the left side would just be the leftovers essentially, x squared dy dx plus 2xy dy dx. Again, just rearrange the ordering just a little bit there.
Yeah.
Okay, so Jake has gotten us off to a good start. He started moving all of the non-dy dx terms over to the right? Any questions? Josiah, what would you think of to do next?
I think I'd add the left terms of the dy dx and the divide by.
So, what should I write?
Did you do 2x cubed? No, would it just be 2xy plus
So that's not really an adding of the like terms, is it? What is that? I'll write down what you said, because what you said is good. The first thing you said, we're going to pretend that you didn't say it. That's the second thing you said, right? That's not really adding like terms. What is that? Somebody's whispering it. No? Think really simple doesn't mean easy. Just think simple. Like, what did we do with the dy dx?
You just made that the factor.
We factored it, right? We saw that the dy dx was in common, and we just factored it out. Does that make sense? Okay.
Oh, man. The way you did it.
Nobody's saying it's easy. If I had $1 for every time someone did the calculus perfect and then blew the algebra up, I'd be really rich. Happens all the time. Just got to take your time, do the algebra right. Nobody's saying that it's like impossible. You just got to do it right. It doesn't mean that it's easy. You know this. All right. So Josiah has done a good job factoring things out for us here. One step remains. What is it?
Division.
Division, yes. So dy dx then equals negative 2xy minus y squared over
So conceptual.
x squared plus 2xy. Okay, did anybody take that all the way through? You don't have to raise your hand here. Did anybody take it all the way through and get it right? If you did, you're doing awesome. A lot of little moving parts that need to be done correctly. Let me ask you a follow-up to that. I don't know if this is true. Hey guys, this is pretty stinging important for you to get this. I don't know if anybody like maybe did this. They took it all the way through and they're like, oh, I see it, and they just made it all work. You might have gotten this. Notice, I did not do this by mistake. Notice I did that. Why are those two things equal?
Because you would factor out a negative one on the bottom.
Isn't it basically I multiplied the top and bottom by -1 or factored out a -1 out of top and bottom, however you want to put that. Those are equivalent answers. Essentially, if somebody got the green answer, they took the dy dx terms to the right instead of leaving them on the left. And there's no real reason that that's wrong, right? Yeah, so if I decide to take things to the left, you decide to take things to the right, we are going to get the exact same answer except all of our signs will be different. It means you still got it right. You just want to be really careful, like if it was a multiple choice, to check through and make sure that you didn't, miss that little detail, because it's an important little detail for sure. Just multiply everything through by -1 and it should work out just fine. Okay?
All right.
Fantastic. So let's do our final question, and this is going to lead us directly into what we're going to do tomorrow. I am ultra pumped about tomorrow. Tomorrow is going to be the very first time that we do anything with applications, and it's fun. So here we go. Number 5. This is the last one. So please remember that in the other ones that we've done, the instructions more or less have been the same. They have been essentially find dy dx and do something with it, right? Find dy dx and find the equation of the tangent line, or find the normal line equation, or whatever, right? That's kind of been the directions. This says differentiate with respect to time. And so I think customarily, every time we use time as something we indicate, we're going to use the letter T. Not X, not Y, not Z, or whatever. We're specifically going to use the letter T. So differentiate with respect to time. Those 5 words mean this. Means we've got this x squared minus 3xy squared plus y squared equals 8. It does not want us to do ddx of everything. It does not want us to do ddy of everything. It wants us to do ddt, right? Because it wants us to differentiate with respect to not x, not y, not z, but t, time. So let's do ddt of everything. Here's what's unique about this. You see any t's in our original equation? That means the chain rule factor is going to show up every single time we differentiate. Okay, so let's start. Let's do maybe the first one together. What would you guess, what would you think that ddt of x squared is? We're doing this one. Somebody's talking about a 3 over there. So 2x dx dt. You just differentiate in an x term, and so the chain rule factor will be dx dt. Let's skip the middle one for a second. Let's skip over and do this one. What do you guys think ddt of y squared is? 2y dy dt. It's not going to be dx dt because we didn't just differentiate an x term. We just differentiated a y term, so it's going to be plus 2y dy dt. And let's do the last term as well. What do you think ddt of 8 is? 0. 0 d8 dt, and d8 dt would just be 0, so 0 times 0 is 0. So now the middle, the one we've left off, is what? A product. Did you see it? Here's how I'm going to handle the product. I'm going to say that the purple part is my 1, and I'm going to say that the red part is my 2. So let's do this together. 1, 3 is negative 3x. d2, what is ddt of y squared? That's right, 2y dy dt. So there's 1d2 plus 2 would just be y squared. d1. Negative 3 dx dt. Good. So then what you're supposed to do with this, we obviously just ran out of time 1 second ago. What we're supposed to do with this is find dx dt. I'll leave this part up to you. So find dx dt. It gives us the x value. It gives us dy dt. And it says to keep your answer in the second quadrant. How do you think you'd find the y to go with that x equals negative 1? Lug it in, right? Keep it in the second quadrant. I'll leave that part up to you. At that point, it's a plug-and-play situation. So tomorrow we will start related rates. It's a truly exciting day. Have a good one.